Hi. Hello. We're continuing with our special right triangles because no one likes playing with the Pythagorean theorem. We're looking for shortcuts, so we need to do the Pythagorean theorem just a few times, set up our patterns, and then we can set the Pythagorean theorem off to the side. Last time we were together, the special right triangles that we were looking at were 45, 45, and 90. Today's special right triangles are 30, 60, 90. They're going to come from an equilateral triangle. So let's start there. Here's my equilateral triangle. What do we know about equilateral triangles? Good. What's equal about them? Good. All the sides. What else? You're not wrong. They're all congruent to each other. Well, similar. Because one could be all ones on the side, and another one could be like threes on all the sides. Okay, all the angles equal 180. And if all the angles equal 180, what does each individual angle have to equal? 60. Yeah, 60. Good. So that means that this angle here is 60, and this angle here is 60. And this angle here at the top, the whole thing is 60. But I'm going to cut this equilateral triangle right down the middle at the altitude. Okay? A for altitude. Now I have a 90-degree angle right here in the corner. I have a 60-degree angle right here. How much does this little tiny one have to be? 30. Because I already have 90. 90 plus 60 is like 150. In order to get to 180, it needs to be 30. So this angle here is 30. That's how we're creating these 30, 60, 90. It's as if I started with an equilateral triangle and chopped it in half, because I'm a ninja. All right, let's look at some sides. Here I have that equilateral triangle again. Here I've cut it at the altitude. And cutting it at the altitude to give me my 30, 60, 90 right triangle gives me a hypotenuse and it gives me a short leg. Take a look at the measurements between the short leg and the hypotenuse. What do you notice? Short leg is 1, hypotenuse is 2. How do you go from short leg to hypotenuse? Okay, I could use the Pythagorean theorem, but if I were trying to shortcut it, not use the Pythagorean theorem, what could I do to the number 1 in order to get the number 2? Multiply. By what? By 2. So I could take 1 and multiply it by 2. Okay. Let's look at this other triangle. Starts off equilateral. I cut it at the altitude. It creates a short leg, because the 90 is there, and it creates a hypotenuse. Can I do the same thing? Can I go from the short leg to the hypotenuse by multiplying by 2? Yes. We found our first pattern, and we haven't even used the Pythagorean theorem once yet. To go from the short leg to the hypotenuse, all you have to do is multiply by 2. Let's double check to make sure this works, okay? Come down here, the bottom triangle. It's equilateral, I promise. Let's cut it at the altitude, go from the corner straight down along the dots, forms a 90. How long is this side? Start from here and count. 1, 2, 3. If I want to go from this short side to the hypotenuse, what does it look like I have to do? Multiply by 2. So this should be 6. Let's check that it is in fact 6. These dots are done so that they're all the right length. Okay, so from here, we're going to count. 1, 2, 3, 4, 5, 6. We found our first pattern. Flip the page and let's look at the bottom and let's apply this pattern to see how quick and easy we can do these, okay? Excuse me. Join me on the back when you're ready. Let's look at number 2. All right, here's our triangle. We have a right angle that makes this the hypotenuse, that makes this the altitude because it's across from the 60, and that makes this the short side because it's across from the tiny little angle. What was the pattern to go from short leg to hypotenuse? Multiply by 2. 8 times 2 is? We're done. We're done. That's it. For the hypotenuse, we still need to find the other leg. We'll do that later. Come down and look at number, excuse me, let's look at number 1. Oh my God, there's a fraction. All right, here's our right angle. Here's our hypotenuse. Here's the 30-degree angle. That makes this the short leg. Here's the 60-degree angle. That makes that the long leg. To go from short leg to hypotenuse, what's the pattern? Short leg to hypotenuse, multiplied by 2. So I'm going to take 1/2 and multiply it by 2. And I'm going to rewrite 2 as a fraction. This lets me see that I need to multiply straight across. 2 over 2. 2 over 2 is? 1. And we're done. Wonderful. Flip back. Let's look at those triangles again. We need to find the next part of our pattern. We've discovered that if we're going from the short leg to the hypotenuse, we multiply by 2. But what happens if I want to go the other direction, from the hypotenuse to the short leg? Divided by 2. Because if I'm going in one direction, short to hypotenuse with multiplication, I'm going to go hypotenuse to short the other direction with division. Okay, let's go play with this. Join me back on the other side. Let's look at number 6. Here's the right angle. That makes this the hypotenuse. Here's 60 degrees. That makes this the long side. Here's the 30. That makes this the short side. How did we say we go from hypotenuse to short side? Divide by 2. 20 divided by 2 is? Is that easy? Let's look at number 3. Because number 3 has an odd number. Zoom out just a little bit. Here's our right angle. This is the hypotenuse. Here's the 30-degree angle. That makes this the short leg. That makes this the long leg. To go from hypotenuse to short leg, I need to divide by 2. 11 divided by 2. I don't care about decimals. We're just going to leave it like that. That's it. That's all there is to it for the hypotenuse. Let's go back to those triangles again, and let's try to figure out that third side. And because I don't know what the pattern is yet, we're going to have to go to the Pythagorean theorem. Okay? Let's start with this first one. This is the one that's C. I've already given this one a letter A, which makes this one B. So A squared plus B squared equals C squared. A, here's B, here's C. I'm squaring everything, subtracting 1 from both sides, and taking the square root. Just like last time, looks like we're generating some square root things at the end. Since we're looking for a pattern, our pattern may have something to do with the square root of 3 thing. Okay? Yes? All right. So let's scoot down. Let's do the next one. And let's see if that square root of 3 thing happens again. Okay? A, B, C. A squared plus B squared equals C squared. I'm filling in B and C. I'm squaring things. I'm subtracting 4 from both sides. I've taken the square root. I have square root of 12. But my pattern looks like it wants a square root of 3. So I should see if I can simplify the square root of 12 and hope a square root of 3 shows up. Because if it does, we found our pattern. Maybe. Okay, let's grab 12. Factors of 12, please. 6 and 2. All right, 2 is already done, so I'm going to leave it by itself. Can I have factors of 6, please? 3 and 2. And I have my pair. And so those come outside of the radical. And the 3 stays inside. My square root of 3 has appeared. I may have found my pattern. Let's do one more to confirm that we may have our pattern with square root 3. Okay? Our next one is going to be this big triangle down here at the bottom of the page. A, B, C. A squared plus B squared equals C squared. Putting in information in B and C. Squaring things. I need help subtracting 9 from both sides, please. 36 minus 9? 27. And so A equals the square root of 27. Again, I want to try to see if this has a square root 3 hidden in it somewhere. So we're going to take 27 and we're going to break it into factors. Factors of 27, please. Factors of 27, please. 3 and 9? Okay. 3 is already a prime number, so can I have factors of 9, please? 3 and 3, and here's my pair. And so A is 3 square roots of 3. And it really does look like the pattern is there. Because if I zoom out, all of my answers contain a square root 3. Square root 3, square root 3, square root 3. Take a look at the triangles and at the results. What's the pattern? What's it look like happened? It's that radical. What did we attach the radical to? Here we attach the radical to the 2. Where does the 2 appear in this triangle? The short leg. Here we attach the radical to a 3. Where does the 3 appear in this triangle? The short side. This one doesn't have anything in front of the radical, so I can assume that it's a 1. Where does 1 appear in this triangle? The short side. So it looks like the pattern goes short side to long side. Just stick a square root 3 next to it. It's multiplication. Okay? Let's play with that pattern, shall we? Turn the page. Come back to number 2. We just discovered that the pattern to go from the short side to the long side is multiply by square root 3. All right. So short side is 8, then the long side must be 8 times the square root of 3, which I just write as an 8 next to a square root of 3. That means multiply them. Easy enough? Yeah? All right, let's move over and let's look at number 6. Slide down to number 6. Short side to long side. What was the pattern? Multiply by square root 3. When you're dealing with whole numbers, that multiply just looks like you mashed them together. So the long side should look like 10 square root of 3. Let's move up to number 3. Put it away, please. Like away. Like in your pocket in your backpack or something. Thank you. All right, to go from short side to long side, what was the pattern? Times square root 3. What was the measure of the short side? 11 divided by 2. So long side is 11 divided by 2. Square root 3. I know it's a weird looking number, but it's fine. Leave it. It's okay. It's good. There's nothing wrong with it. It ain't going to hurt you. Just leave it just like that. Don't put any decimals. Leave it just like that. Let's slide over to number 1. From short side to long side. What's the pattern? Times square root 3. Short side is 1/2. So long side is 1/2 times square root 3. And we done. Now if the pattern was short side to long side multiplied by square root 3, what do you think the pattern would be to go long side to short side? How did we go from short to long? How did we go from short to long? Times square root 3. So how should we go from long to short? Divide by square root 3. Okay? Or, look, see this number is 1/2 right here? Look what's out here. You see it? Over here. This number was an 8. Look what's here. Do you see it? Look again. Short side was this. Look what's in front here. You see the short side? Look what's here. This means this is the long side. Yes? Because here's our right angle. So here's our hypotenuse. Here's the 30-degree angle. So this is the short side, meaning this is the long side. If our pattern was short side to long side, you multiply by square root 3. There's our short side. Do you see it? easy, right? It almost feels like you're cheating at this point, isn't it? You're cheating in math. To go from short side to hypotenuse, what was the pattern? Multiply by 2. So my hypotenuse on this one is? Now look at number 5. Let's color code it real quick. Here's my right angle. That makes this the hypotenuse. Here's my 60, making this my long leg. That makes this one my short leg. I have the long leg. To go from long leg to short leg, you told me the pattern was divide by the square root of 3. And that my shortcut was just grab the thing in front of the square root 3, right? There's a problem. I don't have a square root 3. All right, no problem. My pattern says divide by square root 3. So I'm going to divide by square root 3. Problem. I don't want it at the bottom. It's not 1.5. We're not turning them into decimals either. We're just leaving it as square root 3. I need to get rid of the radical in the bottom of a fraction. It makes all the math people upset. They freak out. Oh my God, radical in the bottom. Okay. So to get rid of radicals in the bottom, we're going to multiply by 1. But it's a crazy looking 1 because that 1 looks like the radical in the bottom. This way, when I multiply straight across, I end up with 12 square roots of 3. And in the bottom, I end up with square root of 3 times square root of 3. This is a times. It's a really big Godzilla of a times. All right, I'm looking in the denominator again. What's square root of 3 times square root of 3? 9. 3 times 3 is 9. So square root of 9. I need to come down here because I'm out of space. So now I have the square root of 9 down there. What's the square root of 9?
3.
Just the 3. I'm still seeing people trying to write the square root of 3. Square root of 9 is not the square root of 3. Square root of 9 is just 3. Okay. Now, but I have 12 divided by 3. What's 12 divided by 3?
4.
Here's our super shortcut. Because this looks like a hot mess. Okay? Our super shortcut. Are you ready for the super shortcut? Super shortcut is divide by 3 and then multiply by square root 3. Super shortcut. Take this number, divide it by 3. 12 divided by 3 is?
36.
Divided by?
4.
12 divided by 3 is? 4. And then we're going to stick a square root 3 on it.
What is it?
We took 12 and we divided 12 by 3. Okay? Once we finished the divided by 3, which we got 4, we stuck a square root 3 onto it. You see it?
Yes.
Okay. Now that we have the short side, we can go short side to hypotenuse by doing what? Times 2. Do not multiply this 2 inside the radical. It does not go in the square root. It's not allowed in the party. It doesn't have a square root. It's not square enough. Only multiply it to the outside of the square root. So 4 times 2 is 8, and then the square root of 3 just kind of hangs out because he's a square root. That's it. Do you want to see one more like this so we can apply the super shortcut? Yes? Okay, one more that looks like that. So come over here to this empty space here. For number 7, Can I please have a number, any number you love?
14.
14. Can we get something that's divisible by 3? No, we'll leave it at 14. It's fine. We'll do 14. It's
21.
fine. It's fine.
21.
You already picked 14.
21.
Do you guys want me to change it to 21?
No.
Okay.
21.
It's fine. It'll just be a fraction. Don't worry about it. It's cool. All right. It's cool, man. Here's our right angle. That's the hypotenuse. That makes this the long leg. Because this is the 30, so this is the short leg. How did we go long leg to short leg? Our rule was divide it by 3, then multiply by square root 3. 14 divided by 3 is, I don't know, the fraction. 14 divided by 3, leave it. And then stick a square root 3 on it. Now that we have the short side, the pattern was short side to hypotenuse, multiply by 2. Just the top number of your fraction, please. That's the only thing that multiplies by 2. So this is 14 times 2 over 3, square root 3. What's 14 times 2? 28. So this is actually 28 over 3, square root 3. That's it. We're done. That's it. We're done. I know. Wow, right? Y'all want to say bye or anything? Because this is a great recording.
Bye.
Bye.